LaurieWinkless is a physicist and science writer. As I said, some people who are nervous flyers might want to sing La 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 for the next couple of minutes, because why is turbulence getting worse, Laurie?
Yes, I'm sorry to be the bearer of bad news on this. So there's some research that's been done by researchers at the University of Reading in the UK, and they're focused on a specific type of turbulence. Now, it's called clear air turbulence. This is a bit unlike the normal turbulence that we are quite used to feeling if you're in an aircraft. That type of turbulence you can avoid. Pilots can fly around it, but clear air turbulence, as its name suggests, is kind of invisible to the naked eye, which makes it very difficult to avoid. And it is also more serious and more destructive. And it tends to happen at the typical kind of cruising altitudes of long haul airplanes. So it is something the aviation sector thinks about a lot. And in this study, researchers, the same group, in fact, had previously predicted that clear air turbulence would increase significantly as a result of climate change. And that's because clear air turbulence is caused by sudden changes in wind speed or direction, which is what we call wind shear. And wind shear tends to happen more in warm air. So they kind of predicted that this would happen. But in this new paper, they've shown that it has actually already started happening. So they took 40 years of weather and climate observations and put them into a pretty comprehensive set of equations that have been tested over the years. And they found a significant increase in the likelihood of hitting moderate or greater turbulence in pretty large swathes of the planet, particularly across the North Atlantic and continental US, which unfortunately also represents some of the world's busiest flight corridors. So yeah, as an example, in one area over the North Atlantic, in 1979, there were 17.7 hours of severe turbulence, and that increased to 27.4 hours of severe turbulence in 2020. So that's quite a big increase. Now, just to reassure people, the absolute risk is low. So in absolute terms, the risk is pretty low. You're unlikely to hit severe turbulence. The probability is still around 1%, right? So it's still pretty low, but this is a large relative increase. So that tells us that these regions really have already increased in turbulence. And unfortunately, because of that, and because of our climate continuing to change, it looks set to become more bumpy in the coming years.
Well, let's look at something constructive and positive, because it's another big problem: waste on all fronts. However, there is a little scientific trick to possibly reducing chemical waste. What is it, please?
Yeah, so it's actually what I would kind of call a fourth type of chemistry. So we kind of have three main types of chemistry that you see a lot. We can use light, and that can break or form bonds. That's photochemistry. There's also electrochemistry, which is about electrical energy, and thermochemistry, which is transferring heat energy. But this fourth type of chemistry is called mechanochemistry, and it involves physically pushing molecules together. So applying a mechanical force to molecules to activate a chemical reaction and form bonds between these chemicals. And these are particularly interesting precisely because these reactions happen without solvents. So you don't need to dissolve your compounds in something else and then join them together. You just combine them directly. And this is a really big deal because solvents currently account for more than 60% of all chemical manufacturing waste. So moving to this type of chemistry could really help reduce waste. And in this research from the City University of New York, they looked specifically at some of the unknowns about mechanochemistry, really fundamental questions like how and why do bonds even form when you press molecules together? So they did this using an array of tiny little pyramid-shaped tips that they covered in one chemical, and then they used a microscope to bring those tips down onto a surface that was coated in a different chemical, and its position could be changed really accurately. And that setup allows them to vary the amount of force that they applied between these two surfaces, and then they could study the resulting chemical bonds. And what they found was that the act of pushing on molecules actually causes those molecules to twist and deform, and they take on a different shape than they would normally, which actually makes them much more reactive than the equivalent kind of non-distorted molecules. So by establishing this really fundamental piece of knowledge that we didn't have about mechanochemistry, this paper has really opened the door to maybe doing this on a more practical level and perhaps even producing chemicals in a more sustainable way.
Really unfair question to drop on you so quickly, but any implication for the so-called forever chemicals?
Not that I've seen in this paper, to be honest, but it does look like the study did show that the deformation of molecules doesn't actually depend on the type of molecule. So they might be able to apply mechanochemistry to a broader range of chemicals than they had previously realised.
Here's hoping. All right, now, sewer robots destroying dinghy-carrying mozzies. How clever.
Yeah, this is really interesting to me. So dengue fever is one of these many viral diseases that are carried by mosquitoes. And in the past 50 years, it's become increasingly common. And this is due to things like increased urbanization, flooding, and warming temperatures. But there's actually no vaccine for dengue fever. So their main attempt to prevent the spread, right? So you really have to get the mozzies before they get us. And in this new paper, scientists in Taiwan teamed up with frontline workers to develop this, what they call an unmanned ground vehicle system, which sounds very fancy, but in effect, it is a pretty simple crawler robot that has been loaded up with lights and high resolution cameras. And they have kind of driven this robot through a series of covered ditches. They're effectively kind of ventilated wastewater pipes in a specific city, Kaohsiung in Taiwan. And as they're driving this robot through the tunnels, they can take images and take video footage and also note its location. And that allowed them to find mosquito eggs and larvae and pupae in about a fifth of the ditches in the city that they investigated. And immediately following that inspection, city hygiene workers could come in, they could flush out those ditches using hot water jets and sometimes insecticides to kill the mosquitoes. So by monitoring the population of mosquitoes using traps, ground traps, they showed that they could decrease the population of adult mosquitoes by about 70% as a result of this kind of early intervention. And this was just a pilot project. So their plan now is to upgrade their robot, make it a bit fancier, and to roll the approach out more widely.
That's really, really clever, and you wonder what else we could use it for as well.
Yeah. Good
stuff. Thanks so much, LaurieWinkless, who is a physicist and a science writer